Alright, let's begin our discussion of the factors that affect dissolving now. So, first and foremost, we have to remember that dissolving happens because of random molecular motion. So, when you have a solute that goes into a solution, or goes into a solvent to form a solution, the only reason that these molecules spread out is based upon that random molecular motion. An increase in pressure above a solvent would increase the amount and the speed of this dissolving process. So what I want you to consider is, if I have a cylinder, I have a container, and above this container there's a plate. If I have a liquid solvent that has some substance dissolved in it, if I were to increase the pressure of the gas above this, if I push down on the plate, for instance, so I push down on the plate, what that does is it compresses the gas molecules on the top, and it causes them to have an increased pressure. Well, this increased pressure can only be relieved by going down into the substance that has some give, which essentially means it'll put more stress, more pressure on these surface molecules. If there's more pressure on the surface, what it does is this will have a much easier, or it'll have a better time keeping these particles dissolved in solution. Another factor that affects this rate is temperature. So solvents are going to move faster at high temperatures. With this in mind, we know that the purpose is, in order to take a solid solute, so let's say this is my solid solute chunk, what must happen is the solvents have to get in, and they're going to have to get around and surround one of these molecules in order to pull it away. They have to do this with each of these particles in order for something to completely dissolve. So the key to this is high temperatures make these solvent particles move faster, so they're better able to surround the solid solute. Now, high temperatures, on the other hand, when we consider gaseous solutes, the increase in the motion of the solvent has less of an effect than the fact that the gases have higher energy. If gases have a higher energy in this solution, what they're going to tend to do is they're going to want to separate from the intermolecular forces that are holding them in place. So if that's the case, a high temperature is going to cause these gas particles to escape from the solution. So high temperatures would decrease the solubility. Okay, so again, in summary, pressure increases solubility. Increase of temperature for solids will increase solubility. Increase of temperature for gases will decrease their solubility. Now, another factor that we have to consider is the solvents have to dissolve the outer solute molecules before they can begin surrounding the inside molecules. So what I like to think about here is kind of like, if you have an onion, every onion has layers. Okay? And in order for you to eat the onion, the first thing you have to do is peel away the outside layers and eat them first. So the same process is going to occur here. When we consider the solvation process, our solvents are going to have to take that first layer and peel it away first before they can have access to the inside layers. So with this in mind, smaller groups or smaller chunks of solids are going to get surrounded and dissolved more quickly. So if we're considering, let's say this is an antacid tablet, okay? Well, if I have a tablet this size compared to a tablet that is half the size, that has been, I suppose, cut in two. So we have the same amount that has to get dissolved. However, this amount can get dissolved more quickly because it's divided into smaller groups, smaller chunks. The way that we describe this specifically is the more exposed surface area. Okay, because thinking again of that pill, we have the half chunk that now has this whole inside area that was previously unexposed. So all of this shaded region here, these are now newly exposed area. They're new particles that the solvent can surround. All right, I'll give you guys a second to go ahead and work these practice problems. I'll assume you've taken that time now, and I will go on. Dissolving happens because of the random motion of the solvent molecules. High pressure above a liquid solvent causes more of the solute to dissolve. How does temperature affect the dissolving process for solid and gaseous solutes? So, increasing temp for solids will increase the dissolving or the solubility, right? Increases the dissolving process. So more will dissolve, and another thing to consider here is that the rate, this is going to happen more quickly. For gaseous, okay, if I increase the temperature for gaseous solids or solutes, then what ends up happening is the higher energy solute particles have more likelihood of escaping, so we have a decrease in solubility. What could you do to speed up the dissolving process for an antacid tablet? What you could do is you could cut it or grind it. Okay, I think the most effective way would be grinding it, because then you're going to have a very fine powder that has a very high surface area. That's what you have to consider. We want to increase the surface area.